Welcome to Making Stuff with Chris DeHut. In this video, we're going to take a look at the simple RGB LED. This is an LED that contains 3 different colors. They look very much like a normal LED, but we'll go into the differences in a moment. In this video, we're going to cover what they are, their applications and reasons for using them. We'll take a look at a datasheet example, an example of how to wire one up in a Fritzing diagram. We'll take a look at it on the breadboard, and then we're going to control each color of it, simply turning it on or off, or turning a couple of colors on at the same time and then off. And then we'll add a little razzle-dazzle with a little bit of fading of the lights on and off. And then that way you can incorporate that into your really cool applications that you'll come up with for these RGB LEDs. The first thing to understand about an RGB LED is it is essentially 3 LEDs inside one package. And you can control each of those 3 LEDs individually. And you can apply different power to each one to get varying intensities of color, and then you can mix that in to get a full wide variety of color out of a single LED. For applications of RGB LEDs, I'm going to look at it more from a practical point of view as the first application. And I want to compare that to how we as humans utilize color to communicate a lot of very important things. You're coming up to a stoplight as you're driving. Red is stop, yellow is caution or slow down, don't go, and green is go. Pretty effectively communicates what we should do, and millions of people do this every day, and it happens millions and millions of times. Most of the time it works quite effectively. A weatherman uses colors on his map to indicate literally everything from wind direction, wind velocity, temperatures, snow totals, rain totals, everything. We as humans were very accustomed to interpreting color very quickly and accurately as to what someone is communicating. And therein kind of is the power of an RGB LED. If you just had a red LED or just a blue or just a green LED or pick your random color, it's kind of hard to communicate very quickly and easily a condition. So a great condition for an RGB LED would be red, there's a warning in your system. Blue, everything is cool and working good. Green might be it just started running, or it could indicate maybe battery power. So you can do combinations of communicating different aspects. The other thing that is a good attribute of the RGB LED is you can use one of them to convey multiple different colors. If we were to put 3 LEDs on our circuit board, it would take up 3 times the amount of space, actually substantially more, allowing for spacing between them. So it's a space savings tool. The other part of the RGB LED where it gets to be much more contemporary, and you'll see it actually in cars. I remember one car I rented a while back. It had, for lack of a better way of putting it, mood lighting down in the floor area of the car. You're driving along and the floor kind of inside the car is glowing kind of a pretty blue. Hot rodders have been putting them on the outside of the cars as well, in the undercarriage area, so there's this glow underneath the car as it drives by. Frankly, it does look pretty cool. Gamers in the computer games here, they put or get lighted keyboards so that they glow in different colors. Accent lighting in the home, we're using that now with RGB LED devices, light bulbs, and so forth. All around, you can add a lot of visual interest with an RGB LED, and working carefully with the colors and with how you're turning those colors on and off, blending them, maybe fading them in and fading them out. So there are a lot of applications. A lot of them are more in the fun thing than in the more serious realm. The important thing to remember is it is a communications device. You're just trying to convey some bit of information, be it for fun or for a serious reason. Now, if you haven't done so already, on our website you can download the Fritzing diagram and you can download the source code and copy it into your Pico and follow right along. I'll have links for that down in the description below. This particular data sheet is not specific to the LEDs that I purchased, so there are some slight discrepancies, but this data sheet does communicate very effectively what I wanted to discuss. What they're mentioning here in the data sheet is that it combines together 3 LEDs, one red, one green, one blue, in a convenient 4-lead package. So think of it that way. There are 4 LEDs inside that package. It'll either have, in this case, a water clear or a white diffused lens over it. That's the outer plastic thing that we see. Here are the absolute maximum ratings. Remember, these are maximum ratings. This is at the point just before the LED explodes. So don't go that high. They're only telling you what the maximum is. Never run at maximum. Especially here, you'll see the peak current at 100 milliamps. You're most probably going to pop it right after that. But what is very important for us and what is unique to an RGB LED has to do with the 3 different colors, red, green, and blue. And if you've played with LEDs at all, you know that depending on the color, they will have a different forward current, or a forward voltage and forward current, the forward voltage being the voltage at which the LED starts to come on. The forward current is the amount of current going through the LED. Now, for this particular example here, for the red colored LED, we're looking at this upper example here, and we're looking at 20 milliamps for the test conditions, and that's 20 milliamps of current. Here is our symbol here, VF, forward voltage, right here. This is telling us what the forward voltage is and the current that we would run at. So in our case, we would say 2 volts. And to calculate our current limiting resistor, we take 3.3 volts, which is what we're providing from the Pico, minus 2, and then divided by 0.02 for 20 milliamps. And then that would give you your resistance. I'll put the formula up on the screen. Now I want you to see we're on red, here's green, and here's blue. The common on all 3 of these is 20 milliamps of forward current, noted by IF. What is different, red is at 2 volts forward, green and blue are both at 3.2 volts forward voltage. So we could use the same current limiting resistor for green and blue, but red should definitely use a different one. If you only have one value or you just want to keep things simple, use the higher of the resistor values, the higher ohm rating for all 3 of the LEDs, and then that way you're on the safe side. They have a mention of a note here. You can create different colors from red, green, and blue by mixing them together. If you turn on red and green, you'll get a color different from turning on blue and green at the same time. If you turn all 3 of them on, you'll get pretty much closely to white. If you want even more color choices, we would vary the power, so to speak, going into it with pulse width modulation. And we'll be touching on that in one of our examples. Very importantly is the package description. Here we're seeing the LED package. It's got 4 legs. We are using, in my example, common cathode, which here is pin 1, cathode. That's our negative, very nicely detailed. So that is this pin. This pin, leg, is number 2. That's red, and that's where we would apply a positive voltage. And then pin 3, this one, or leg 3, would be green, positive voltage would be applied, and then 4 would be our blue LED. And all these work this way. You've got your common cathode, your ground connection. Up in here are the three LEDs, red, green, and blue. And they all come back through the common cathode. So you need to study this carefully when you wire up your RGB LEDs to make sure you're putting the power into the right leg and the ground on the right leg. If it doesn't work, just you're not generally going to blow them up. Just look at it at the diagram again and work through it. The Fritzing diagram makes it very nice to see how everything is connected and wired together. Here we've got a Raspberry Pi Pico. This is our ground pin number 38. Comes down to our ground rail over to pin number 1. Now you might look at that very cleverly and say, hey, Chris, you got to wire it up backwards. No, it's just rotated 180 degrees. We're looking at it from the back side as opposed to the front side shown in the data sheet. So this one is my pin number 1, as it'll be laid out on the breadboard, the actual breadboard, as we'll see in a minute. So that's our 0 volt line. And then I was very clever in my pin selections and my wiring. I'm going to start out with, on pin number GP26, I've got a red wire for, guess which LED? That would be our red LED. And that is going through a 68 ohm resistor. For our green LED, that's going through GP number 27, through a green wire, through a 10 ohm resistor, and into the green leg of the LED, and then finally GP 28 going through the blue wire, through a 10 ohm resistor, into the number 4 leg of the LED. And again, we noted that green and blue are very close in power requirements, voltage requirements, forward voltage, etc., so they can use the same resistor. Coming over to the actual breadboard, you can see the connections are identical. It's just inverted on this axis, the y-axis, and I don't know why I did that, to be honest with you, but we've got our ground wire coming over to the ground rail, pin 1, plugs directly into the ground rail, and then we've got from left to right red, green, blue legs going through 68 ohm, 10 ohm, and 10 ohm resistors into the red wire, going back to 26, green wire 27, blue wire, GP number 28. Now let's take a look at our first program example, and it's going to be very, very simple. In the comments above, I'm saying this is a RGB color LED. We're going to just simply go full on and full off with our control of each of the colors. A commentary about how to wire it up. We've already went through that, both on the Fritzing and on the actual breadboard. Making a note, common cathode LED is used, meaning that the common is connected to 0 volts or ground, and then we're supplying voltage to each of the LEDs individually. We're going to load in a couple of libraries that are very common in MicroPython programs. We're going to load in the machine library, which gives us access to the hardware, and we're going to load in the time library, or microtime library, so we can create some dwells in here, giving us a little bit of time in between each of the changes in color. We're going to create 3 objects, a red LED, a green LED, and a blue LED, noted by RGB LEDs. Those will be machine.pin objects, and we're going to assign the pin number for each of those objects. And we're going to set those pins up as outputs. So we've got R_LED equals machine.pin. We're going to use GP number 26, and that pin will be set up as an output. We repeat that for the other 2 LEDs. I'm going to set up a variable here for a pause in between certain actions in our loop down below, and I'm going to give it 2 seconds of pause time. When we start running it, it'll say ready, set, go. First thing I'll do is turn off all the LEDs so that I'm at a clean starting point. Then one by one, I'm going to turn on an LED, first the red one, then the green one, then the blue one. Then I'm going to mix up some colors. I'll turn on the red and the green at the same time, and then turn it off. Then the red and blue at the same time, and then the blue and green at the same time, on and then off. Then I'll go through, turn them all off at the end, so that when we come back through, we're in the same state when we turn them off again at the top. Obviously not needed down here. It's just habit for me to make sure I put things back the way I found them. And then finally here, I've put in a few pauses, and I'm going to take 2 of those out just to speed things up in the video. It helped me to make notes while I'm going through debugging this. Now, I would like to mention that on the camera right here that's showing the breadboard, it's not showing the color of the LEDs. I had this on a previous video and I could not get that camera to resolve the colors. So I took that camera and pre-recorded the same thing so that I could show you better when we're talking about colors. That camera picks up colors much better than this camera. So you might see a couple different angles here. Hopefully you can follow along. We're going to fire it up and we'll run this program. And you'll see the red comes on, then green, then blue. Then we're mixing red and blue, mixing blue and green, and red and green. And then it just repeats all over again. Now, again, you can imagine if we mix the colors, here we've kind of seen how it goes with a mix at full power, full on for each of the different LEDs, the red, the green, and the blue. Now, you can get more variation by varying the intensity of each of the individual colors. And that's what we're going to talk about next when we use pulse width modulation to fade the colors in and out. So we'll stop this program. Now let's take a look at fading the colors on and off of each of the 3 LEDs that are inside this RGB LED package. Coming into the program, the top part's basically the same. We're going to import the same libraries. What we are going to do different, we're not going to create just simply a machine.pin as an output. We're going to create these objects as a pulse width modulated output, PWM signal. I've got another video covering PWM in great detail, and I would highly recommend you view that video to get a better understanding of what all these bits and pieces mean within this program. So essentially, we've got our red LED. It's going to be a PWM signal on pin 26, and we want that to run at a frequency of 1000. And I'm going to do the same for our green LED and our blue LED. I'm going to set up a variable to give us a rate at which we fade in, fade on, and fade off. And it's just a number that I picked and tweaked it a little bit, and it seemed to work fine for what we're trying to communicate. We've got another variable, V, which is holding the duty cycle for the PWM signal. We're going to vary that duty cycle. And then we'll run the program and then get right into the loop. In our main loop of the program, I'm just going to start out by turning all LEDs off, so I've got a normalized state from which to start with. And then I'll explain this particular one, and then it's the same as the other ones. But this is our red LED that I'm controlling. And I'm going to say while V is less than or equal to 655, 535, which is the maximum range for the duty cycle. And that range is 0 to 655.35, with 0 being off and 655.35 being very bright, full intensity. So that'll be our duty cycle as it goes through this loop, fading on. We're going to increase V by 2, starting at 0, and then ramping all the way up to that amount. This line here, our LED dot duty underscore U16 is setting that value with the variable V of the duty cycle. We're setting the duty cycle to that value in V. And then we'll sleep for a very brief time, and that's just to slow it down. Otherwise it happens really, really fast, and you can't see what's going on. Now for dramatic effect, you would variable your fade rate, or you could vary the increment amount to make it go faster or slower. And then finally, once it gets to full intensity, we'll fade it back out. So we're in a loop while the duty cycle is greater than 0. We will decrement our duty cycle by 2, set it on the LED output pin for that PWM signal, and then we'll sleep, and then it'll fade back out again. We repeat that for the green, the blue, and then we're going to go in and do red and green at the same time and mix the colors, fading it on, fading it off. Same thing with red and blue, and then green and blue, and then all 3 of them. So let's take a look at that. We'll go ahead and run it, and you'll get an idea of how it will look. Now, as you can see with the basic fade on and off with the single color portion, that's kind of a cool effect, and it's a little nicer than just simply going on or off. When we start blending the colors, we're blending the intensity of both colors the same amount, so it's more of an intensity of that particular color. You could also alter that intensity for just the red or just the blue and mix up your duty cycle change for each of the colors, and that would give you a different color or different shade of color. You can have an awful lot of fun mixing your own colors by giving each LED a different PWM signal value. The greater the value, the brighter that particular color will be. They don't all have to be at the same level. You could be at PWM duty cycle for red at 20,000, green at 10,000, and blue at 30,000. You can mix it up however you want, and then that way you can get a great variety of colors, intensities, and effects. So all around, these RGB LEDs are very effective communicators. I'll say mostly these days it's more for style and mood and cool looking things, but they do have practical applications as well. As I alluded to earlier, I'm also doing a full series on the Raspberry Pi Pico with a wide variety of interface and program examples where we're working with all different types of devices, from temperature and humidity to displays, obviously LEDs, switches, just the full gamut of things that are typically interfaced with a microcontroller. There's going to be a link down below in the description that'll take you to our companion website where all this is indexed very carefully. So it's easy to pick which video you want to watch. Of course, you'll see this on the YouTube channel as well. With that, I think that'll conclude our discussion on the RGB LEDs. They're just fun devices. If you've enjoyed this video, I certainly hope you'll subscribe, maybe even give me a like. And there's this notification bell thing that I think if you click on that thing, it will alert you of when the next video is available, as I'm publishing these out at a rate of about 1 a week, and that'll go on for, I think, about 30 or 40 weeks from right at this point going forward with the number of videos I have planned. Thanks again for spending some time with me today, and hopefully you picked up a few things along the way. I look forward to seeing you in the next video.